Approximately 15 months ago, in the early 2024, a lot of people, including myself, got super excited about a potentially once-in-a-lifetime event. The event referred to as the Blaze Star, or an appearance of a sudden, relatively bright star in the night skies that was not there previously and would have been visible with the naked eye. And that's because this new star would be produced by an extremely massive explosion. Not a supernova, but a phenomenon referred to as nova, and specifically a recurrent nova, implying that this is a repeating event that's supposed to happen every once in a while. In case you're not familiar with this is essentially a phenomenon involving a white dwarf and some kind of a partner star, where the white dwarf, which is a much smaller but also a much more dense star, accumulates a lot of material around itself, which then, as the pressure and density starts to build up, explodes, producing an enormous thermonuclear reaction, essentially resembling an enormous hydrogen bomb. And although nova by themselves are no longer that surprising and happen a few times per year, only extremely rare nova end up being so bright that they become easily visible without any telescope and without any binoculars. For example, here is Nova Eridani, visible in 2009. And so, for practically 15 months now, all of us have been waiting for this sudden explosion that should technically produce one of the brightest stars in the entire galaxy. Because the star itself, Cor Borealis, was predicted to explode approximately every 80 years, with the last explosion right here in 1946. But because prior to the explosion it actually dimmed just a little bit, and because a similar dim was observed in 2023, this is why this particular explosion was expected to happen in 2024. As a matter of fact, several theoretical studies started to come out around the same time, trying to predict the explosion in order to potentially explain what's happening around the star, assuming of course the explosion happened. And this would be pretty remarkable. Its total magnitude would technically be similar to Polaris or the North Star, and it would be visible from practically everywhere. But as of late June of 2025, basically 15 months later, still nothing. Every theoretical prediction and every assumption so far has been proven more or less incorrect. And though we have no idea why it didn't happen yet, right now almost everyone is certain that it will happen, it just seems to be a little bit delayed. For example, in one of the recent studies, scientists proposed some kind of a third hidden star that might be disturbing some of the material being deposited on the white dwarf and may actually cause the explosion sometimes in November of 2025. But I guess we'll see if this is true, if it actually does happen on this date. And so I guess we're just going to have to wait until then. But to everyone's surprise, another star that actually nobody knew even existed basically said, "Hold my beer." And it just created the brightest nova we've seen in a very long time. And so on June 12th of 2025, the automated system known as Assassin, or All-Sky Automated Survey of Supernova at Ohio State University, detected a completely new point of light, and a point of light that was rapidly brightening. And within just a few days, it basically changed its name several times, because at first it was believed to be a supernova, then it was believed to be maybe some kind of a different unknown explosion, but by observing specific parameters, researchers definitively determined that this was a completely new, bright nova. Another massive stellar explosion surrounding a white dwarf that by June 16th was given a new official designation. It was now known as V462 Lupi, because it was located in the constellation of Lupus. But intriguingly, within just a couple of days, by June 18th, it was already bright enough to be visible with the naked eye, the magnitude of 5.7. And that's actually what surprised everyone, because not only is it still brightening, this is the first such bright nova in the last 5 years. The last one was in the early 2021, and this was RS Ophiuchi. You can learn about this in one of the videos in the description. And though it is located in the southern sky, making it slightly easier to see from the southern hemisphere, it can also be seen from North America, Europe, and Asia, just after sunset if you look to the south. And obviously it would be much easier to see this if you did have a telescope or binoculars. As I mentioned, it is visible to the naked eye, but probably just for a few more days, maybe a week maximum. Because there's a high chance that by early July, it might become very difficult to see, as most nova usually brighten dramatically and pretty quickly, very often reach their peak brightness within just a week or so, and then start slowly fading for weeks and sometimes months following the initial explosion. But here it's really the brightness that's kind of shocking. It's at least 4 million times brighter than the original star that was seen here previously a few months back. And because this is the first record of V462 Lupi, we have no idea when and even if it will explode again. But just the fact that it seems to have produced a very similar explosion to what was expected from the blaze star, also known as Cor Borealis, makes this a super exciting discovery, even though it's a completely different star. And that's because generally, these naked eye nova are extremely rare. Most of them are not bright enough to be seen without telescopes, and as I mentioned, the last one that was easily visible was back in 2021. And that's despite the fact that at least 9 or 10 of them are detected every single year. There are actually several sites in the description, such as this one by Koji Mukai, that essentially track nova for several years now and has a list of all of them in the last few years. And there's another older catalog by Bill Gray that goes back several decades. And on average, we usually detect 10 in the Milky Way galaxy, with a few more potentially visible in the nearby Andromeda galaxy too, because it's close enough and these events are usually pretty bright. And in case you're wondering, here are the 4 nova detected in 2025 so far, but none of them as bright as this one. And it's actually uncertain why this one is so bright. Because unlike a typical supernova, which rips the star completely, a classical nova only affects the outer layer of the star, where the more massive white dwarf pulls away enough material before having all of it explode all at once. And so in terms of theories, there are still quite a lot of unanswered questions, as nobody actually knows exactly how they work and why some of them happen quite frequently. Other ones, like Cor Borealis, seem to have a pretty long period between explosions, yet other ones, like this one, seem to maybe just happen once, or have periods in hundreds if not thousands of years. And so I'm sure there are going to be several studies in the next few months trying to explain why exactly this was so extremely bright. But you might still have one question here, at least I do. If you wanted to see this, what's the easiest way? Well, assuming you have a smartphone, and assuming you're outside in the dark, one of the best tools would be Stellarium. It does come in different versions, but this is a free open source project that uses your phone navigation to try to help you find different stars and different constellations, and you're basically looking for this location. First find the constellation Lupus, and then try to find the circled location, and here you should be able to see a relatively dim star that might not be listed in the catalog or might not be visible inside Stellaris, but should be visible if you look in the right spot. Now personally I haven't seen it yet myself because it's unfortunately raining here, but I'm definitely looking forward to seeing this once the clouds disappear. And well, that's pretty much all I wanted to mention. After months and months of waiting, we finally get a new nova visible in the night skies without any binoculars, even though it's not exactly the one everyone was waiting for. But this one might end up being even more exciting because, well, why did it explode so brightly? And what exactly is happening around this star that we actually didn't even know existed until it became so bright? And so we'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, maybe support this channel on Patreon where you can find additional videos and videos without any ads, or by joining the channel membership where you get early access. Stay wonderful, I'll see you tomorrow, and as always, bye bye.